Good morning, children. So, now moving to the next part of the topic, relationship between zeros and coefficients of a polynomial. So, let us take one by one linear polynomial and quadratic polynomial and cubic polynomial. First one, linear polynomial. General equation or general form, I should not say equation, general form of linear polynomial is ax plus b. So if the polynomial p of x is equal to ax plus b, then what is the 0 of the polynomial mean? For that value of x where p of x is 0. Now you equate p of x to 0. That means ax plus b is equal to 0. So thus what you are getting, x is equal to minus b by a. So directly, without doing anything, directly you can find out the 0 of the polynomial using the coefficients. What is a? A is the coefficient of x. What is b? Here in this case it is constant term. So here in case of a linear polynomial, minus constant term by coefficient of x gives you the 0 of the polynomial. Let us see an example. So example 2x plus 3 is the given polynomial. So now 0 of the polynomial, 0 of p of x is equal to, according to the formula, minus b in the sense here it is minus 3 by a is here 2. So this is how you can directly determine 0 of the polynomial. So important relationships, you need to remember them. Okay, right. So then next, moving on to the quadratic polynomial. General form of the polynomial is ax square plus bx plus c. Here c is a constant term, b is the coefficient of x, a is coefficient of x square. A is coefficient of x square. Please remember, in the general form you have plus everywhere. You have plus everywhere. Suppose in the problem you are given minus 5x. It means minus 5 is the coefficient of x. Remember that. That's very, very important. Right. Now let us suppose if alpha and beta are the zeros. Because why we are taking 2? Here it's a quadratic polynomial. In a quadratic polynomial you have 2 zeros. So alpha and beta are the zeros. Then sum of the zeros relationship is given by alpha plus beta is equal to minus b by a. And product of zeros alpha into beta is given by c by a. So minus b by a, that is minus of coefficient of x by coefficient of x square. Alpha into beta, that is a product of zeros, is constant term divided by coefficient of x square. Okay, so this is how this is the relationship between sum of the zeros and product of the zeros. Let us do an example and then solve the things. Right, so x square plus 7x plus 10. Suppose if the problem is asked to find out sum of the zeros, alpha plus beta is equal to minus b by a. So this is b. So minus 7 by a. This is a. What is the coefficient of x square? 1. So that is equal to minus 7. And the product of zeros. Product of zeros, alpha into beta is equal to c by a. C being the constant term. 10 by a is the coefficient of x square, which is 1. So that is equal to 10. So alpha plus beta is equal to minus 7 and alpha into beta is equal to 10. So this is how you can find out the sum of the zeros and product of the zeros. Sometimes he will ask us to find out the zeros and then verify whether these are true or not. Right? Such problems also you have to find. Then you have to find out which one satisfies the 0 here. Right? And then 2 zeros after determining, you have to assign the value 1 to alpha and 1 to beta. And then you have to find alpha plus beta separately. And then using this formula, you have to find out b minus b by a. So thus when both are equal, it means it is verified. Okay, children? Right. Pause the video for a moment and take the screenshot. Linear polynomial with example. Quadratic polynomial relationship with example. Now let us do a problem. Find the zeros of the polynomial. So that just now we discussed about it. X square minus 3 and verify the relationship between zeros and coefficients. Okay, so now let us solve the problem here. So here x square, p of x is equal to x square minus 3. I can write it as x plus root 3 into x minus root 3. Why? Because a plus b into a minus b is a square minus b square. So using this identity, I can make this sum as a product of two terms. So now from here it is very clear. If x is equal to minus root 3, then you will get a 0. Or x is equal to plus root 3. So minus root 3 plus root 3. So therefore it will become 0 and thus p of x can be 0. So therefore I'll write it as p of x is equal to 0 when x is equal to plus root 3 or x is equal to minus root 3. So therefore we got both the zeros, right? Therefore zeros are alpha is equal to root 3 and beta is equal to minus root 3. Now find separately alpha plus beta. So root 3 minus root 3, which is 0, and alpha into beta, root 3 into minus root 3, it is into, dear children, it is within the brackets of root 3 of minus root 3, plus into minus, minus root 3 into root 3 is 3. So let this be equation 1 and this be 2. Okay, so we have sum of the zeros is equal to 0 and product of zeros is equal to minus 3. Now our job is to verify whether the relationship is correct or not. So what is that we have to find out? Minus b by a. So from coefficients. Minus b by a. So what is minus b by a? So here compare this with the general thing. Compare with the general equation. What is the general equation? I'll write it here. So what general equation is ax square plus bx plus c. A general polynomial is ax square plus bx plus c. So now compare this with. So what do you have? X square minus 3. So you don't have b term. So what is a is equal to? Coefficient of x square is 1. B is 0. Right, and c is equal to minus 3, right? Like this you have to compare and then write. And then now minus b by a is equal to 0 by a is 1, which is equal to 0. Now what is the next one we have to find out? C by a. C by a is equal to, what is c? Minus 3 by a is 1, which is minus 3. So now let me write it as 3 and 4. So from 1 and 3, alpha plus beta is equal to minus b by a. Yes or no? Yes. Right. And then now from 2 and 4, alpha into beta is equal to c by a. So hence verified. So this is how a problem will be asked from polynomials. So from polynomials, usually you'll be getting a graph related problem for 4 marks. It's a guarantee problem. Every one of you should be very thorough to find out the zeros of the polynomial and then locating the xy coordinate points in the plane and then joining the graph and finding zeros from the graph. Without a question from graphs from polynomials, there is no public examination paper. The other thing, for 2 marks, so definitely some of these questions may come. So polynomials is very, very important chapter, dear children. Minimum of 6 and maximum of 7 marks. Minimum of 6 and maximum of 7 marks you will be getting from polynomials. And the chapter is also very, very easy. There is no so much logic, no so much twisting. It is straight, substituting, finding zeros, and then really it's very, very easy. So remember to score more from this particular chapter. Okay. So now take the screenshot. So what did we do? First we determined the zeros, and then we found sum of zeros and product of zeros. So we kept them aside. Then we determined minus b by a and c by a using the coefficients. And when we observed, we got alpha plus beta is equal to minus b by a, and alpha into beta is equal to plus c by a. So that means it is verified. Take a screenshot, copy the notes. Now moving on to the cubic polynomial. General formula. Children, remember, what is very important is writing the general formula. Whenever a problem is given, please write down the general formula and compare it with the given polynomial. Then only you will be able to do it. So general form of the polynomial, cubic polynomial, is ax cube plus bx square plus cx plus d. So remember, highest power is getting the coefficient always as a. Then next one is b, next is c, next is d, next is e. If suppose you have power 4 also, of degree 4 also, right? So therefore cubic polynomial, you have p of x is equal to ax cube plus bx square plus cx plus d. So now a, b, c, d are the coefficients. If alpha, beta, gamma, cubic polynomial, so you will have 3 zeros. Let the 3 zeros be alpha, beta and gamma. Then sum of the zeros, alpha plus beta plus gamma is equal to minus b by a. And alpha beta plus beta gamma plus gamma a, alpha. So that is c by a. And finally, product of all the 3 zeros, alpha, beta, gamma, is equal to minus d by a. Okay children, so this is what you are supposed to remember. If by mistake also, if you write wrong formula to find the products and all that, then complete problem is gone. So be careful. So take the screenshot and copy the notes. Then afterwards we shall do an example problem. So moving on to the example, verify that 3 minus 1 minus 1 by 3 are the zeros of the cubic polynomial. Right? So first of all, we have to see what are the relationship of the cubic polynomials. So 3 minus 1 by 3 are the zeros of the cubic polynomial. P of x is equal to 3x cube minus 5x square minus 11x minus 3. And also verify the relationship between zeros and coefficients. So what did I say you? You have to always write the general form. You can write in the problem itself. Comparing with general form. That is ax square, it is cube, is it not? Cubic polynomial, ax cube plus bx square plus cx plus d with 3x cube minus 5x square minus 11x minus 3. We get, what do we get? A is equal to 3, B is equal to minus 5, C is equal to minus 11, D is equal to minus 3. So these are very important, A, B, C, D. After determining. Now what is the first thing? He gave zeros. Right? And he is telling us whether these are zeros or not to be verified. Okay, let us do the first one. So case 1. So now substituting in P of 3 is equal to, so now 3 into x cube is 3 cube minus 5 into 3 square minus 11 into 3 minus 3. So now let us see. So 3 into 3 cube is 27 minus 5 into 3 square is 9 minus 11 into 3 minus 3. So 3 sevens are, so 3 20s are 60, 3 sevens are 21, 6 plus 3 twos are 6 plus 281 minus 5 nines are 45 minus 33 minus 3. So this is, so 81, leave it as it is. Now add all the negative values. Minus 45 minus 33. Did we do any mistake? Or is the problem right? Alright, so therefore minus 878 minus 3, right, perfect. 81 minus 81, so we are getting it to be 0. So hence verified. First one is verified. So similarly, second one. What is the second one? What is the number given? P minus 1. P of minus 1. So 3 minus 1 whole cube is minus 1. Minus 5 minus 1 whole square is 1. Minus 11 into minus 1 minus 3. So this is minus 3 minus 5 plus 11 minus 3. So minus 3 minus 5 minus 8 minus 8 minus 3 minus 11 plus 11. So this is 0. Now next one is P of minus 1 by 3. So that is 3 into minus 1 by 3 whole cube minus 5 into minus 1 by 3 whole square minus 11 into minus 1 by 3 minus 3. So you simplify this and verify, it will come out to be 0. Okay, right. So please simplify this. Don't leave it like that. So okay, I'll only do this. So it is minus 1 by 3 whole cube is minus 1 by 3 cube. So therefore minus 3 by 3 cube minus, this is minus, it will become plus, it is square. So minus 5 by 3 square. Minus of minus plus 11 by 3 minus 3. So therefore this will be coming as 1 3 and this is 3 square minus 1 by 3 square minus 5 by 3 square. You can also make this one plus 33 by 3 square, right, minus 9 by 3 square. So you got everywhere to be 3 square is common. So therefore this is my way of simplifying it. You can do your own. So it is minus 1 minus 5 plus 33 minus 9. Okay. So therefore minus 1 minus 5 is minus 6. Minus 6 minus 9 is minus 15. So minus 15 plus 33 by 3 square. So we are not getting it to be 0. It should be 0, no doubt. So children, you verify. If I did any mistake anywhere. So here the mistake is, see, while we are taking this one by 3 square, in the sense you are dividing it with 9. So multiply with 9, you will get minus 27 by 3 square. So thus you will be getting it as, so minus 27 minus 5 32 minus 1 minus 33. So minus 33 plus 33, that is equal to 0. So thus we got it to be 0. So now we have verified that 3 minus 1 and minus 1 by 3 are the zeros of the given polynomial. So take the screenshot and copy the notes first. Then afterwards let us verify the coefficients also, relationship with coefficients. Take a screenshot. So last one, it's up to you. I took the LCM part. Just I wanted to make the common denominator and then did the simplification. It's up to you how you wanted to do. You do that. Now let us find sum of the alpha plus beta plus gamma. So sum of the zeros. What are they? 3, 3 minus 1 minus 1 by 3. So here also 3 minus 1 is 2. So 2 minus 1 by 3 is 6 minus 1 by 3, which is equal to 5 by 3. Equation 1. Now find out alpha beta plus beta gamma plus gamma alpha. So alpha beta. So 3 into minus 1. 3 into minus 1 plus beta gamma minus 1 into minus 1 by 3 plus gamma alpha, that is minus 1 by 3 into 3. So now let us see, minus 3 minus of minus plus 1 by 3. Now this is 3 will get cancelled. You are left with minus 1. So minus 1 minus 3 is minus 4. Minus 4 plus 1 by 3, that is minus 12 plus 1 by 3. So that is equal to minus 11 by 3. Let this be equation 2. Now product of the zeros, alpha, beta, gamma. So that is 3 into minus 1 into minus 1 by 3. So minus into minus plus 3 will get cancelled. So you are going to get this as 1. So this is equation 3. So we determined alpha plus beta plus gamma, alpha beta plus beta gamma plus gamma alpha, and then alpha beta gamma separately. Now let us find out the relationships with coefficients. That means we are going to determine minus b by a, c by a, and minus d by a. So now minus b by a is equal to, so what is minus b by a? So what did we get minus b to be? B is minus 5. So minus of minus 5 by a is 3. So that is plus 5 by 3. And then next one is c by a. What is c? C value is minus 11 by a is 3. So that is minus 11 by 3. Then finally it is minus d by a. What we have to determine? So minus d by a is equal to minus of minus 3 is d by a is 3. So that is 3 will get cancelled. Minus of minus, it is plus 1. So let us name these equations as 4, 5 and 6. So what do we conclude? So 1 is 5 by 3, which is 5 by 3 here 4. It is minus 11 by 3. This is minus 11 by 3. This is 1. This is 1. So therefore from 1 and 4, what you can conclude? A plus alpha plus beta plus gamma is equal to minus b by a. So next from 2 and 5, what can we conclude? Alpha beta plus beta gamma plus gamma alpha is equal to c by a. And from 3 and 6, from 3 and 6, what can we conclude? Alpha into beta into gamma is equal to minus d by a. Hence verified. Hence verified. Okay children. So pause the video here, take a screenshot and copy the notes. And this is how you have to verify the relationship between zeros and coefficients of the polynomial. So with this, today's class is done. So do the related exercise and post me.